Hello, welcome everyone. Welcome to a new virtual tour of the European Southern Observatory, or simply ESO, its acronym. My name is Farid Char, and with the producer Hector Salas, we are going to be your guides during this virtual tour in the La Silla Observatory. Just a little bit about me. I am one of the tourist guides of the Paraná Observatory, actually, for more than 10 years. But of course, I also know some specific things about India. And I have been working in astronomy outreach and education for more than 15 years. Um, but today I am not alone, as I told you already. I am with the producer Hector Salas. So, how are you, Hector?
Hi Farid, happy to be here once again. I'll introduce myself. My name is Hector Salas. I'm a PhD student at the Leibniz Institute for Astrophysics in Potsdam, Germany. I work mostly with topics related to the circumgalactic medium, that is the environment that immediately surrounds galaxies. And I have been a member of the team of guides for Parallel Observatory since 2019. I started when I was doing my master's in Chile in Antofagasta. And today I'm the producer here, so we changing the pictures, the videos, but I will also be reading all your comments. So please feel free to send all your greetings. That if you have any questions or any doubts, just send it to us. And during the tour, we have a couple of instances to answer any question you may have. So please just send all your questions.
Thank you very much, Hector. So, yeah, ESO wants to be with you during this virtual experience and bring astronomy directly to your home or wherever you are. So, yeah, you can send your questions or comments, and later we are going to answer them. Also, you can share this experience using the share buttons on Facebook or YouTube. Okay, so we are going to start immediately, and we are going to explain in first place some facts about the organization, about ESO. So ESO is an intergovernmental organization composed of 16 member states. Its headquarters are located in Germany, and also Australia has joined ESO, but in this case as a strategic partner. Chile is the host state and is the home of all ESO observatories. So around the 60s, and with those objectives in mind, ESO did choose one of the best places on the planet for astronomy, for astronomical observations, the Atacama Desert in Chile. So around that time, our country had started an exploration campaign of several sites to attract international observatories, such as ESO, to our country. So in this case, Chile offered its territory, and ESO did choose the more suitable area. So the mission of ESO is about to design, build, and operate astronomical observatories, and what for? Well, to enable important scientific discoveries and incentivize the promotion and cooperation in the astronomy field. Now, you will see a picture in a few moments with the three observing sites of ESO in Chile. So first, we have the Paranal Observatory. This ESO observatory is the home of the Very Large Telescope, or VLT. This is right now the most advanced visible light telescope on Earth. In the future, and near Paranal, we will have the Extremely Large Telescope, or ELT. This will be the biggest visible light telescope on the planet. And near there, near Paranal, we will have also the CTA, the Cherenkov Telescope Array. This will be an array of different telescopes, in this case, focused on capturing gamma rays. Now, we also have Chajnantor. Chajnantor is the site of the ALMA radio telescope. So in this case, ESO is a part of this radio astronomy observatory alongside other international partners. And last, we have the place of our visit today, La Silla Observatory. This is the first ESO observatory in Chile. And this place is located in the Coquimbo region in the north of the country, in the north of Chile, at 2,400 meters above sea level. So we are going to visit this place in the next hour. Okay, so we are going to do a virtual trip to La Silla Observatory, and you will see a picture of our planet. So we are going to start this trip in Europe because I need to remind you that ESO is an European organization. And in this map, outlined in white, we can see the different states, I mean the different ESO member states. And Chile is participating as the host state, so it's the home of all ESO observatories. So in this animation, we are traveling to the Andes Mountains, to the Chilean mountains. So we are flying over the Atlantic Ocean, and I want to tell you a little bit more about the mission, the main mission of ESO. So you need to understand that the work of ESO is about to imagine what type of instruments we need to study the universe. So ESO needs to design the pieces, to build the telescopes, and to operate those telescopes, and taking care of all observing requests from astronomers from different countries. So in this case, we can incentivize the promotion and cooperation in the astronomy field. We are almost arriving, and you will see a very amazing mountain. You will see different mountains there, and you will see the animation, in this case, of La Silla Observatory. Um, La Silla Observatory is, well, basically a very old place, but it's very, very important to the present day. We have a lot of different telescopes there. And this place was chosen by the astronomical community as a place for astronomical observations at the beginning of the 60s. La Silla has a big number of clear nights per year, a quiet atmosphere, a dry atmosphere, and dark skies. Okay, in this animation, well, in this video, we can see the different telescopes in La Silla. You can see the names. Right now, we have 10 telescopes in operation in La Silla. This observatory was inaugurated in 1969, and some of the telescopes that you can see in this video are not in use anymore. So that's why I say right now we have 10 telescopes in operation, but two of them are operated directly by ESO. The other telescopes, many of them are robotic, so they belong to other institutions. We can operate remotely, all of them, and ESO can basically support the operations in the telescopes that are operated remotely. Okay, so ESO is currently operating the 3.6-meter telescope and the NTT, the New Technology Telescope. So in this picture now, this is basically a 360 view. We can see the 3.6-meter telescope here. We can see the NTT telescope here, the New Technology Telescope, and we can see the different other telescopes of this observatory here. I will do a rotation of this view so you can see better this place. Well, we can see a sunset there. This is very beautiful. In this, yeah, I know in this picture you have some clouds, but as I told you already, we have a lot of clear nights per year. It's about 280 or something like that. So later you will see actually a real picture of the night sky from La Silla, so you need to pay attention to that. But basically, this place is located in the middle of the Atacama Desert. So that's why you can see a lot of mountains. Of course, all of this area is very dry, very isolated. This is a former radio telescope in La Silla, the CEST. It's not in operation anymore. In this view, I can show you the east. So these are the Andes Mountains, very high mountains, in the limit with Argentina. And now I will come back to the main picture. So you can see the 3.6-meter telescope. Okay. So essentially, as I told you already, Um, we are going to visit the two telescopes that are operated by ESO directly. We are going to start with the 3.6 meter telescope because this was the first telescope to be inaugurated. Okay, I am going to access this telescope now, and now you can see how it looks. So essentially, we are in the interior of the 3.6 meter telescope. Um, what the La Silla staff is calling this telescope the 360, just because of the, well, it's 360 centimeters. Um, in this telescope, we have a very specialized instrument, a highly specialized instrument, and this instrument is called HARPS. The HARPS is an instrument looking for exoplanets. So basically, it's looking for planets orbiting other stars, not our sun. And and this instrument is actually very successful at doing that. Okay, so I am going to explain more later. Now, if you see carefully, the dome is huge, right? The telescope, of course, is a giant telescope, and the dome, the enclosure, is huge as well. Now, from the first floor to the dome, we have 25 meters, okay? And all the structure of this telescope equals to a seven-story building. So you can imagine more or less the size of this big thing. Now, in order to understand even better the size of this telescope, if you look carefully, you will notice that there is a person there in this picture. Um, so in case you haven't seen the person yet, the person is here. Okay, so let me show you. We have a person standing there, so you can understand how big is this telescope. Now, in order to understand what happens with this big structure, I am going to explain a little bit using a picture. I will display a picture now. Give me a second. Okay. So we have a few things that we can distinguish from the picture to the right. First, in dark blue, I mean this area, we have the structure that is basically holding the mirror, okay, and holding all the telescope structure. So this thing is basically the mounting of the telescope, okay. So the mounting is holding the telescope and is providing the movement for the telescope. So during the night, we have to point this telescope to different locations in the sky. So the mounting is providing this function. So anytime the telescope moves and is pointing to a different object, the mounting is acting there. Okay. Now, if you look at this area, in this light blue area, this light blue structure, this is the telescope's body. Okay. Um, in this telescope body, we have the primary mirror of 3.6 meter. Okay. This mirror is not visible here because at this in this picture is protected by this kind of systems of tabs. Okay, we have something here, as you can see, covering the mirror because we are trying to avoid dust or moisture. So we need to protect the mirror when the telescope is not observing. Okay, so that's why we have a system of tabs here to cover the mirror. The mirror is concave. Okay, it's not a normal mirror. It's not a mirror like the mirrors in your home. This mirror is like a spoon. Okay, so it must be concave because in the top we have another mirror. We have a secondary mirror. Okay, the secondary mirror is in charge to concentrate the light that was first collected by the primary mirror. So essentially, when you have the light coming from the stars, the light is going to the primary mirror first, the light is concentrated because remember it's a concave mirror. The light will be concentrated, will be reflected to the secondary mirror here, and the light will be reflected again. And this light, the physical light, has to pass through this hole in the middle. Can you see? There is a hole there. So the light is going to pass through this hole, and and this light is going directly to the instrument. Okay, so this is how we are receiving light, and the instrument will be in charge of converting the physical light into a digital signal. This is the mechanism to receive and convert this light, the light from the stars. Okay, okay. The instrument, the harp instrument, by the way, is not here. I mean, it's not visible here because it's not physically in this area. The instrument is totally isolated in another room, in another floor of this building. Now, the 3.6 meter telescope, or the 360, started operations in 1977. And at that time, it was a challenge for the engineering of that time. And, and of course, it was a big challenge in terms of the mission of ESO as an organization. European astronomy was just getting started to build an even bigger telescope. Okay, but at this time, in the late 60s, um, La Silla, and specifically the 3.6 meter telescope, um, we can define this telescope like a telescope in the 4-meter category. Okay, because at that time, in the late 60s, this was the biggest and most advanced category of mirrors of telescopes, and essentially La Silla telescope was one of the biggest telescopes on the planet in the late 60s. So that's why La Silla is a very, very important place for astronomy in general. Now, why it was necessary to have a telescope like this, I mean, so big? Because in astronomy, we analyze our objects through its light. Okay. Now, the more light we collect, the more we can learn about them. In this case, if we have a big mirror, okay, of course we can analyze more light, and we will have more information available to study. We can distinguish fainter objects, and we can distinguish more specific details. Now, if you want to know how this telescope is moving at night, we have a very short video to show you the motion of this telescope. Okay, so it was very impressive, of course, because remember, this is a huge machine. And you need to understand in this point that a mirror for astronomy is not an ordinary mirror. So the shape and the surface of this kind of mirror must be perfect at the level of fractions of millimeters, or in order to get the necessary precision, accuracy to observe our objects. Now, in the 70s, in the late 60s and the beginning of the 70s, it was necessary to manufacture a mirror very special, extremely thick. In this case, the mirror of the 3.6 meter telescope, this mirror is 53 centimeters thick. Okay, this is the thickness of this mirror. And this mirror is also very heavy, of course, 11 tons. So this is the equivalent of, let's say, 2 African elephants. And if we want to build even bigger telescopes, we need to find, of course, other solutions because, well, astronomy is always evolving. And the next step in the case of ESO, okay, and La Silla, the next step was done with the New Technology Telescope, the NTT. So essentially, we are going to visit in a few moments the NTT because this was, well, you can consider this the evolution of La Silla in terms of the manufacture of mirrors and telescopes. Okay, but essentially this is what happens with the 3.6-meter telescope. This is a very impressive, wonderful machine, and it is still under operations after more than 50 years. So it's very, very interesting. Okay, so at this point, I would like to know if there's any question from our virtual visitors. Hector?
Uh, there are no questions so far, so let me ask you one of the usual questions that we get in like in-person tours at La Silla panel. What kind of maintenance is necessary to do to the telescope here?
Yeah, maintenance is very important, of course, and especially regarding the mirrors, because the mirrors are the most delicate part of any telescope. So, in the case of the mirrors here, I will show you the picture again. So, in addition to this well protection system, normally when you want to keep the mirror in optimal condition, for example, in Paraná, this is very very common. We need to do let's say an easy maintenance involving an element of a carbon dioxide snow. This is something like a foam. Okay, so essentially for this kind of easy maintenance, we need to rotate the telescope a little bit. So usually one or two engineers will spread this carbon dioxide snow on the mirror, basically to remove dust. Okay, because after all, we are in the desert, in the middle of the desert, we have dust. So we need to use this element to remove dust. And this is, well, as I told you, it's an easy maintenance. You need only a few people, and usually you do this only once a month, and that's it. But for this telescope and for Paranal, of course, we need to do another more complex maintenance every 2 years approximately. So this kind of more complex maintenance involves to extract the mirror, the entire mirror, because we need to apply a process on the mirror that is called a recoating. In this point, I need to mention that the mirror, well, the mirror is something like a special material. It's a solid material. It's not glass exactly, and the surface is a very thin layer of aluminum. Okay, so essentially the surface, the area of the mirror that is reflecting light, is a very thin layer of aluminum. But this aluminum can be changed every 2 years. So when you go for the recoating process, you need to remove this aluminum layer with special chemicals, and you can put a new aluminum layer. And this process is called the recoating. So after this process is over, after 3 or 4 days, you usually put again the mirror in the telescope. So you have to reinstall the mirror there, and the telescope will be ready again for observations. So that's why a telescope so old like this one, more than 50 years, can still work, because the mirror is the same original mirror, but you need to do this recoating every 2 years. So essentially, that's why the mirror looks like new. Yeah, that's the main purpose of the recoating, to keep the mirror in optimal conditions, the surface like new. So basically, you can still observing. So that's what I can say about the maintenance of the mirrors.
Okay, thank you for it. And maybe you can tell our viewers about how to visit the observatory in person for those of them who had the opportunity to travel to Chile.
Yeah, sure. You can visit La Silla Observatory because we have a weekend visits program. This weekend visit program is free for everyone. You don't need to pay anything, but you need to go with your own means of transportation. So in this case, La Serena is, well, you can say La Serena is the biggest and closest city to La Silla, and the trip takes about 2 hours and a half or something like that. So you need to plan in advance. But essentially, you can visit for free, but you need to do an online booking. So in order to do that, you need to visit the ESO website, and you can find a section there about the public visits. So essentially, when you want to visit La Silla, you need to consider that you have visits every Saturday. You have a tour at 10 a.m. You can visit also on Saturdays from September to March in another time at 2 p.m. And Sundays is also available, but for from April to August. And this additional tour is at 2 p.m. Okay, so you have all those options, and when you arrive to La Silla at the entrance, you will have a special bus from the observatory to take all the visitors to the mountaintop. And at this point, you will have a regular tour with tour guides, and they are going to show you all the observatory during the day, to show you the facilities, to explain everything. And this visit takes about 2 hours and a half. So yeah, so essentially you can do it. You need to do an online booking, and I recommend to do it in advance, at least 2 weeks in advance, because sometimes maybe everything is fully booked. You have limited spots. So, but essentially, yeah, you can visit the observatory.
Okay, thank you for it. I think it's time we continue with the tour, and we'll have another instance later to answer more questions. So please, if you have any doubt, just send it to us through the chat. And now let's continue now.
Okay, thank you. So yeah, we are going to continue now, and we are going to leave the 3.6 meter telescope. We are going to come back to the main screen, and before continue to the next stop, the NTT, I want to highlight the differences regarding the domes, for example. So if you consider, I am going to do a little close up here. You can see this dome is the NTT, okay? And this one is the 3.6 meters. Now, you need to consider that both telescopes in the interior, you have a telescope in the NTT, and the telescope looks smaller, but the mirror is technically or very, very similar to this one. I mean, it's almost the same size. The NTT in the interior, you will find a mirror very similar in size to this one, but you will see that the telescope structure and the dome, the enclosure, is much more compact. And this is very, very important because the NTT was inaugurated in 1989, and the dome is smaller, very compact. It's an octagon shape and with a system of flaps. So this is basically an evolutionary leap in the construction of telescopes, because it was possible to host the same kind of instruments or even bigger instruments in smaller structures. I mean, lightweight and much more efficient when you need to. I mean, when it comes to keep under control the circulation of air in the interior. So essentially, this dome, the 3.6 meter telescope, you can consider this like a classic observatory, a classic telescope dome. Okay, but this kind of design, right now you can consider this a little bit more obsolete in some aspects. Okay, now we are going to explore the NTT because, as I told you already, this represented a, an evolutionary leap in the construction of telescopes. Okay, so we are going to access the NTT, and here we are. And if you remember the structure of the telescope, of the 3.6-meter telescope, in this case, you can see how this telescope structure, I mean the enclosure, is much smaller. Okay, so in this case, this building, you can see that it's very different. This building, this enclosure, is technically attached. Is technically part of the telescope. I mean, the telescope is here. The enclosure is this structure. Okay, and if you look carefully, when the telescope needs to rotate, the enclosure is also rotating. So this kind of telescope and this kind of enclosure is very special because everything is rotating. Okay, all this enclosure is rotating, and well, of course, if the telescope needs to ti- uh, to be tilted, well, yeah, of course, you can do it with the mounting. Okay, but when you need to rotate the telescope, everything rotates. Now, regarding the size, well, we don't have a person here in this picture, but we have a door. So you can imagine more or less the size of a person. And in this case, the telescope, as I told you already, looks much smaller. Okay, but the mirror, this mirror, is technically very similar, almost the same size of the 3.6-meter telescope. Okay, so let me explain this. This mirror, I will show you from the other side. This mirror, I will do a zoom in. This mirror here is 3.58 meters of diameter. So as you can see, it's almost the same of the 3.6-meter telescope. Okay, again, 3.58 meters in diameter. This is the diameter of the entity mirror. Okay, now this mirror also is thinner, 24 centimeters thickness, and is lightweight, more or less lightweight. It's only 6 tons. So this is the equivalent of one African elephant. Okay. Now, this mirror is also concave. It's like a spoon. Okay, it must be like this because of the design. But there is something very interesting in this mirror, and that's why you can call this telescope the new technology telescope. You can see that underneath we have something. There is a structure here. Okay. Now, in the inside, because it's not visible because of this thing blocking here, we have 75 actuators underneath. We have a kind of piston, okay, acting on the mirror. So essentially, they are applying a small pressure on this concave mirror. And why they need to do that? Because the mirror is heavy, okay? 6 tons is what is more lightweight than the 3.6-meter telescope, but it's 6 tons, so it's heavy anyway. So when this mirror is tilted, when you need to point to different positions, locations in the sky, just because of gravity, physics, the mirror can suffer some distortions or deformations. So if we allow the mirror to have this deformation, the quality of your final picture will be affected. So the actuators are basically compensating any distortion on the mirror. So the concave shape of the mirror will be preserved and the quality of your final picture will be the same. So essentially, the active optics system is helping the mirror to preserve the quality of the information. Okay, that's why we call this technology active optics, because we are applying we are doing a kind of active action on the mirror. Okay. Now, the active optics system was developed by ESO, and this represented, as I told you already, a technological advancement and fundamental for the construction of the next generation of telescopes in the 10-meter category or 10-meter class. For example, today you can find the active optics system in practically all modern observatories, such as the Very Large Telescope, the VLT, at the Paranal Observatory. And in the future, we will also have the active optics system in the Extremely Large Telescope, or ELT. Okay, now something important to mention about the people. Where are the people? Where are the astronomers? Well, in La Silla, you can find about 30 people. You don't need a lot of staff. You have some astronomers, you have some scientists, technicians, okay? And they need to work, of course, during the night to do the observations, but they don't need to be here. They are not inside of the entity, and they are not inside of the 3.6-meter telescope. They are located in a dedicated control room. And from this place, they are supervising the observations. So we have a short video to show you what happens in the control room at night. And you can see here that it's a very simple place. It's basically several computers, as you can see there. We have two workstations in this picture. The workstation to the left is for the NTT, and the workstation to the right is for the 3.6-meter telescope. So you can see a few people working there. You normally need a telescope operator and an astronomer. And they are basically working from there to supervise all the observations, so they can receive the pictures. They can do the remote control of the telescope. So everything is done from there. Okay, so this control room is physically located in La Silla, yes, but it's not inside of the telescopes. Okay, it's a dedicated place to do these night operations. Okay. Now that you know a lot more information about the telescopes and the people working here, I want to invite you to take a look at the main scientific milestones from all ESO observatories. I mean, from La Silla, Paranal, and Chacnantor. Because you know, the observations from all those places are very, very important. And we were able to observe a lot of different objects near our planet, the solar system, but also others located in the most distant places of our universe. So please pay attention, because now we are going to show you a list of the most important discoveries from the ESO sites.
Observations with ESO telescopes have led to many breakthroughs in astronomy, and over the years have been responsible for some truly remarkable findings. Here is our list of ESO's top 10 astronomical discoveries so far. Astronomers using ESO's Very Large Telescope have discovered by far the brightest galaxy yet found in the early universe, and found strong evidence that examples of the first generation of stars lurk within it. Stars that were previously only theoretical. These massive, brilliant objects were the creators of the first heavy elements in history. Elements that are necessary to forge the stars we see around us today, the planets that orbit them, and life as we know it. ESO telescopes have provided definitive proof that long gamma-ray bursts are linked with the climatic explosions of massive stars, therefore solving an enduring mystery. A telescope at La Silla was also able to observe the visible light from a short gamma-ray burst for the first time, showing that this family of objects most likely originates from colliding neutron stars. Astronomers using ESO's HARPS instrument in 2010 discovered a planetary system containing at least 5 planets orbiting the Sun-like star HD 10180. They also found evidence that 2 other planets may be present, one of which, if confirmed, would be among the lowest mass exoplanets ever found. Newer observations and reanalysis of the data suggest that there could be even more planets around this star. ESO's Very Large Telescope was used to detect carbon monoxide molecules in a remote galaxy, seen as it was 11 billion years ago, a feat that had remained elusive for 25 years. This allowed astronomers to obtain the most precise measurement of the cosmic temperature at such a remote epoch, and it matched the temperature predicted by the Big Bang Theory. The atmosphere around a super-Earth exoplanet was analysed for the first time using the VLT. The planet, which is known as GJ1214b, was studied as it passed in front of its parent star, and some of the starlight filtered through the planet's atmosphere. The atmosphere was found to be either mostly water in the form of steam or dominated by thick clouds or haze. Using ESO's VLT, astronomers measured the age of the oldest star known in the Milky Way. At 13.2 billion years old, the star was born in the earliest era of star formation in the universe. Uranium was also detected in a Milky Way star and used as an independent estimate of the age of the galaxy. The VLT obtained the first ever image of a planet outside our solar system. The planet, which has a mass about 5 times that of Jupiter, orbits a failed star, a brown dwarf, at a distance of 55 times the average distance between the Earth and the Sun. In 2014, ALMA, the Atacama Large Millimeter Submillimeter Array, revealed remarkable details of a solar system that is forming. The images of HL Tauri were the sharpest ever made at sub-millimeter wavelengths. They show how forming planets are vacuuming up dust and gas in a protoplanetary disk. One of ESO's proudest moments came when 2 independent research teams, including ESO staff, arrived at a truly revolutionary finding: that the cosmos is not only expanding, but that it is doing so at an increasing rate. The findings of the separate teams were based on observations of exploding stars, or supernovae, including measurements made from ESO's telescopes at La Silla and Paranal. This discovery was rewarded with the 2011 Nobel Prize in Physics. And finally, several of ESO's flagship telescopes were used in a 20-year study to obtain the most detailed view ever of the surroundings of the monster lurking at the heart of our galaxy, a supermassive black hole. Astronomy is always moving forwards, and ESO's top 10 scientific discoveries are not set in stone.
Okay, this was the top 10. I hope you like it. We have something else. We have something extra as a bonus track. So this is not recent news, but it's very relevant anyway. A team of astronomers was able to capture the first picture of a black hole. The Event Horizon Telescope, or EHT, an array of 8 ground-based telescopes distributed on the planet, and thanks to an international collaboration, was able to get the first direct visual evidence of a supermassive black hole. So the picture will reveal the black hole in the center of Messier 87, a massive galaxy in the nearby galaxy cluster in the constellation Virgo. So this black hole is located at 55 million light years from Earth, with a mass of 6,500 million times the mass of our Sun. Okay, so this is the bonus track. And of course, all of this is very, very incredible, incredible discoveries from the ESO telescopes. and the scientific staff behind that. Now we are going to continue with something very, very special. We are going to explore a little bit the night sky from La Silla, because in this picture you can see how looks like a clear night from this observatory in the Coquimbo region. So in this picture you can see we have no moon, and we can see a very, very starry night. So we are going to explore a little bit more about some objects and regions here. So this is the entity, by the way, and next to the entity in this picture you can see a very popular constellation near the horizon. So this constellation here I will show you is Orion. Do you see? So Orion in the mythology is a hunter, okay? And it's very easy to recognize because, for example, you can see three stars there somewhat aligned, and those stars are representing Orion's belt. Okay, so this constellation is visible from the northern hemisphere and the southern hemisphere, so everyone can observe Orion at some point of the year. Um, Next to the Orion's belt stars, we have some interesting here, and this is a nebula. This is the Great Orion's Nebula. So essentially, this is a star-forming region, and it's very bright, it's very big, and it's a very popular object for amateur astronomers because you can observe this object even with your naked eye in a very dark and clear night, of course. You can see this object like a distorted spot in the sky, but of course it's very, very easy to observe with binoculars or even a small telescope. So the Great Orion's Nebula is one of the most popular objects in the night sky. Now if we continue exploring this area, I will go up a little bit and you will find this star, and this star is the brightest star in the sky. This star is Sirius. Sirius is the brightest star, of course, of the Canis Major constellation. So the constellation related to this star represents a dog, one of the hunting dogs of Orion. So essentially, the constellation of the brightest star in the sky, Sirius, is connected in the mythology to Orion. Okay, and both Orion and Sirius, the Canis Major, are visible from both hemispheres, northern hemisphere and the southern hemisphere. But also, if you look carefully to this area, all this area, you will see that this portion of the sky, in this portion you will find more concentration of stars, right? So of course all the sky is full of stars, but here you have much more concentration of stars, and this is because all of this is one of the arms of the Milky Way, our galaxy. So if you look carefully, you will find a lot of different objects here, dark nebulas, bright nebulas. You can find deep sky objects. You can find hydrogen clouds. It's very, very beautiful and impressive. And during the winter months in the southern hemisphere, you can also find the center of the Milky Way. So this is one of the most impressive things from the southern hemisphere, that you can see all the Milky Way all night. Okay. Okay. We are going to change the view a little bit because I want to show you a different sector of the sky. I want to focus the view on those spots. What is this? Maybe can appear like clouds, right? Well, essentially, this couple of objects are galaxies. They are the Magellanic Clouds. This is the Great Magellanic Cloud, and this one is the Small Magellanic Cloud. Now, they are not clouds, of course. They are galaxies, and they are irregular galaxies. They are also satellite galaxies of the Milky Way. So they are orbiting the Milky Way. Okay, those objects are only visible from the southern hemisphere. And the name, Magellanic Clouds, is because of the first person to record those objects officially was Ferdinand Magellan during its circumnavigation of the planet in the 16th century. So basically, at this time, uh, no one was aware of what a galaxy is. So that's why they put in the records clouds, but not galaxies. Well, the Great Magellanic Clouds, as I told you already, are visible only from the southern hemisphere, and the same applies to the smallest constellation in the sky. And the smallest constellation in the sky is here, and it's called the Southern Cross. The Southern Cross in this picture looks a little bit tilted, but it's very easy to recognize. Do you see? So the Southern Cross is located in the middle of another area full of stars, as you can see here, because this is the another arm of the Milky Way, and it's a very beautiful area, of course, in a dark night like this one. Okay, now again, if you are an amateur astronomer and for any reason you want to come to Chile someday, this area is only visible from this hemisphere. So probably one of the first things you want to take a picture is the Southern Cross or the Magellanic Clouds. That's why I am pointing at those objects. Now, if I show you the 3.6 meter telescope, this is another very impressive view because in the background, you can see the center of the Milky Way. So essentially, all this area is, of course, very bright. In this area, you have the constellation Scorpius, and you have a lot of different and beautiful objects, deep sky objects, nebulas, star clusters. And in this picture, the Milky Way is rising. So you need to understand that in the winter months, as I told you already, I mean in May, June, July, in the southern hemisphere, you can expect to observe the Milky Way all night. And this is a big difference if you compare with the northern hemisphere, because in the northern hemisphere, I know that you can also you can only observe about the 75% of the Milky Way or something like that, and a little bit near the horizon. But from this hemisphere, you can see all the Milky Way. I want to show you another perspective from the mountain top of the 3.6 meter telescope here. If you look carefully, well, the picture, of course, is beautiful, but in this picture in particular, you can see some glare there. This is essentially light pollution from La Serena. And I want to point at this because light pollution is a very important and serious problem for astronomy in general. So any observatory wants to keep the nearby light pollution under control. So that's why in Chile we have some regulations and legal regulations to keep the light pollution under control, to not affect the dark skies because they are part of our natural heritage. Okay, and we are almost finished with this virtual experience. So the last thing I want to do is to show you La Silla Road at night. This is essentially a small road connecting all the telescopes. Do you see? This is the road. You can see the telescopes of La Silla. All of them are connected by this small road there. And this road is also connecting with the control room and with the hotel. So the last stop of this virtual visit will be precisely La Silla Hotel. So in the hotel, we have essentially the dormitories, we have the restaurant, we have all the necessary facilities for the staff. As I told you, we don't need a lot of people working in La Silla, but when they need to work here, they have all the necessary comfort. They have a place to rest, and they stay here. This person in this picture is the photographer in charge of all the pictures that you saw in this virtual tour. And I want to show you that this picture in particular was taken on the during winter, because I want to show you the sky, and you will see something very, very beautiful. You will see the center of the Milky Way in the zenith. Do you see? So all this view is possible only from the southern hemisphere. So that's why many astrophotographers like to come to the north of Chile, the Atacama Desert, to enjoy this kind of beautiful view of our galaxy. Okay, so with this picture, we are going to finish this regular explanation, and I don't know, Hector, if we have some last, question or something from visitors.
There are no questions from our visitors. So,
Mhm.
given the time, I think we can just start finishing things up. So, from my side, I would like to say goodbye to everybody and thank you for watching this stream. We are doing these virtual tours for Paraná Observatory and Sea Observatory every Saturday. We're alternating between both of them and also between Spanish and English. So keep an eye on our social networks to see when the next tour is going to be and which observatory and in which language. And if you know anybody that is interested in this type of content, please let them know that we're doing this.
Yeah, that's right. Thank you very much, Hector. And essentially all this visit information, pictures is all available on the ESO website. So you can visit and know more about any topic you want. And yeah, we are going to uh, have a new virtual tour next week. We are alternating Paranal, La Silla, Spanish or English. So from my side, I hope you enjoyed. And on behalf of VISO, I want to say thank you very much for your virtual presence. Thank you and goodbye.